If we want to make a fine quality or shirt or the pant according to our size, we always visit to the tailoring shop and the tailor take the measurement, and according to the measurement they made a beautiful shirt. And if they are not taking the measurement or they are taking the wrong measurement, they will cut the clothes accordingly and it will be completely waste. So it is always saying that cut the clothes according to the sizes, and the same thing it is true in our cases also. Whenever we are dealing with the reinforcement, if the reinforcement is cutting in the wrong places, that means whole reinforcement is waste. So we need to know how to cut and how to bend and how to place the reinforcement so that the wastage will be minimum and it will be according to the sizes and the requirement. And the whole process is called the bar bending schedules. So in today's video, I will discuss what is bar bending schedule, what is the key component of bar bending schedules, why bar bending schedule is important, and what is the step-by-step procedure of the bar bending schedules. So stay tuned until the end to get the full information about the bar bending schedule. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload any new video, you will get immediate notifications. Now start with the subject. What is bar bending schedule? Bar bending schedule is a huge subject and it cannot be covered in single videos. Then it will be a long form video. So I will make it part by part. So today is the basic or introductory about the bar bending schedule. In the very next part 2, part 3, I will discuss how to calculate and how to cut and everything. So let's start about bar bending schedule. The first thing, what is bar bending schedule? According to the bar bending schedule is a detailed document that provides information about the reinforcement steel bar used in a reinforced concrete structure. Now, in the structural drawing, it is always there what bars to be placed and what bars to be required. Maybe it is saying 16 tor at the rate of 115 center to center. That means 16 dia bar to be placed and its spacing is 150 millimeter. But then why bar bending schedule is required? Bar bending schedule is detailed. In the structural drawing, it is only mentioned the dia of the bar and the spacing of the bar. But what will be the length and how to cut? Because we have the 12-meter diameter bar as a standard one. Other may be required in the long big projects as per their requirement, but that is not the special cases. Most of the cases it's coming into 12-meter. But how that 12-meter can utilize in our projects? Maybe it's required 6-meter. So and then a U bar or the L bar is required. But what will be the L length of the L and what will be the cutting length? That thing is to understand, because the people who are doing the work, they need to provide the cutting length, and according to they will cut. Maybe 7-meter required, so 7-meter, and now the 5-meter bar is in my hand. How to use this bar 5-meter? Because if it did not use that will be in a wastage and it will be a project wastage, and we should not make that one. Then again the project cost will be high. So it is the detailed drawing and the detailed document that provides diameter of bar, cutting length and everything, so that any layman or any engineer can easily find out that this is my cutting schedule, and accordingly I will cut the reinforcement so that there will be wastage will be minimum and bar will be as per the requirement. And the bar bending schedule, what it will provide, it includes details such as the bar size, number, length, shape and placement in a structural element as per the construction drawing and the design specification. So what is this? Bar diameter, bar size, length. As I told earlier also, the length is not mentioned in the structural drawing. It is only showing the diameter and the center to center spacing. But from the foundation drawing or the beam drawing, we need to calculate the length, and accordingly we need to provide the length, cutting length to the bar bender or the fixer so that they can make this one. So it is required in the detailed format. Without this bar bending schedule, it is impossible to perform the structural work or the reinforced cement concrete work. Otherwise, the steel fixture or the layman will cut the steel as per their own, and there will be a total mess up and total wastage, and the required bar will not be in the same places. It will be a product non-conformity. That's why bar bending schedule is really important. Now next part is why BBS is important or bar bending schedule is important. Detailed reinforcement requirement. how it is saying BBS provide detailed information about the type, size, and quantity of reinforcement bars required in various parts of a structure. Now, in the structural drawing, it will only shows that what is the diameter, what is the spacing, and how it will be placed. But how to quantify? Well, how much quantity of reinforcement is required for the project or for any structure or any buildings? This bar bending schedule will give that assessment that we need 100-ton reinforcement or 120-ton reinforcement, whatever it may be. So it will quantify the exact requirement of the reinforcement of the projects, and also it will ensure the right type and amount of reinforcement are used in each structural component aligned with the project specification or the design specifications. So what will be the bar dia, what will be the length, and where it will be top reinforcement or the bottom reinforcement or the skin reinforcement or the link bar or the hook, what type of bar and what will be the sizes and what will be the shape, that detailing is there in the bar bending schedule. That's why the detailed reinforcement is required, and the bar bending schedule is important, crucial. There is no other such things that can provide the details other than the bar bending schedules. Then accurate placement of reinforcement, specify that exact location and configuration of each reinforcement bar in a structure. Suppose we have beam, and now beam we have the top reinforcement, bottom reinforcement, top extra, bottom extra, and the link bar, the shear bar, and the different spacing and different size of the link bar. Now how to place and how to make? In the structural drawing, it will only mention this the extra bar, this is the extra bar. What will be the extra bar length, and how it will be placed, and how it will be cut, and how it can be minimized, the wastage. So exact things will be in the bar bending schedule, and it is ensuring accurate placement during construction. I am minimizing the error, enhancing the structural integrity of the finished product. So where I have to use, suppose T1, T2 top reinforcement on B1, B2 bottom reinforcement, and how it will be placed. The drawing will be there. There will be a bar mark that is the bar mark B1, and in the cutting length also there will be B1. So from the drawing itself, we will find out the B1 is the bottom bar, and these are the length. Also, it will be placed in the bottom. So in that way, we can ensure that the accurate placement of reinforcement. So that's why the BBS is very much important. And then material optimization. It is quantify the required amount of reinforcement material, including bar length and diameter. Now we any contractor companies, when they need to order the reinforcement as per the dia wise, 8 or 8, 10, 12, 16, 20, 25, 28, 32, whatever. But how to calculate? In the structural drawing, it will only mention the 25 dia, 20 dia. It's like that. How to confirm and how to get the order, how to the material requirement, how to calculate. Only thing is the bar bending schedules helps in optimizing material uses, minimizing wastages, and controlling construction's cost. So this is also the same thing. It will ensuring the minimum your wastage. How? I have 12-meter dia. So I will cut the bar so that it can be used in some places, and the other part also can be in the some places, so that the wastage will be the minimum. And that is only possible if we use the bar bending schedules. Otherwise, the steel fixture will cut the reinforcement as per their requirement, and there will be a wastage, and it will the cost of the project will be more. The next is cost efficiency, as I discussed. So contribute the cost efficient constructions by preventing unnecessary overuse of material, and supports project budgeting also, because it helps to optimizing the material of reinforcement. And then the quality control, because this is really important, how to maintain the quality control of the reinforcement work, because reinforcement is the backbone or the spinal cord of the concrete. Without the steel, it is impossible to make the huge structure. So these are the backbone. So it should be quality control will be high. So if there is no BBS, we cannot control the quality as per the site. So enforce adherence to specified design standard and codes, and enhance the overall quality of the structure, ensuring it meets or exceed industry standards for safety, durability, and the performance. So it is the quality control is will exceed or it will be minimized, or it will be match the project's requirement. So if we have the BBS, we can place the bar as per the requirement, and we can also check as per our requirement also. So that's why bar bending schedule is requirement. Any reinforcement work without the bar bending schedule, it is really nearly to impossible, and it will lead to error, and it will raise the product non-conformity. So that's why the bar bending schedule is very much important. Next is, what is the key component of bar bending schedule? For this bar identification, each type and size of reinforcement bar is assigned a unique identification number for easy reference. Suppose we have bottom main bar and the bottom distribution bar, and the top bar and the top distribution bar, and the skin reinforcement and the link bar maybe. So bottom main maybe we will make is the B1 is the bottom main, and B2 is the bottom distribution. Say the similar way, T1 bottom main, T2 bottom distribution, and the skin reinforcements SR skin reinforcement. So bar to be identified as per their location, so that anybody can easily find out that this bar is for that places, and we will place that bar in the same places, and whenever people are checking, that we can find out that this bar is there or not. So it is bar identification, then bar details. Information of the diameter, length, and shape of each bar is specified. So each bar, what will be contained in the BBS? Bar diameter, bar length, bar shape, like U bar, L bar, crank bar, link bar, hook bar, stirrups, is all the shape will be there in the bar bending schedule. And the bending shapes and dimension. The BBS outlines the bending shapes and diameter of bar, ensuring they confirm the design requirement. And the lap length and the splicing. It is very much important because we have 12-meter diameter is a standard. Now, suppose a beam is around 18 meter. Now, we don't have the 18-meter bar. Now, we have to splice the bar. Now, how to splice and where to splice? Because we cannot splice in anywhere in the structure, we need to splice wherever in the splice zone itself. No, in non-splice zone or the no splice zone, we cannot splice. So accordingly, the bar cutting schedule will be changes. Maybe it's not 12 and 6, it's maybe 8 or 10. That's why we make it 18. So 10 meter and 9 meter, whenever they will have overlap, it will make 18-meter bar diameter. But we cannot make 12 and 6 because maybe in that cases it will fall in the no splices zone. So that is not acceptable as per the design criteria. So according to the splice zone, we need to splice, and that splice detail also to be provided in the bar bending schedule, so that whenever we are working or we are checking, we can find out this is the splice zone, and here there is a splices of the bar is there, and the precise location of the bar. The BBS ensures that the reinforcement bars are placed exactly where they are needed according to the design. If it is a documented and it is mentioned everything that bar will be places here and the bar will be places there, and the diameter, shape, everything will be there. So these are the key component of the bar bending schedules. Now, what is the steps? What are the steps we need to follow to provide making the bar bending schedule? First thing is understanding the structural drawings. I have made a detailed video about this understanding of the structural drawing. You can find out the link in the description or here. So click the link and watch that, so that you will find out how to read the structural drawings. The first things we need to know what is structural drawings and how to read, and whatever mentioned in the structural drawing, diameter of the bars, spacing of the bar, and accordingly then we will process for the identification and scheduling. And then whenever identification and scheduling is there, then bar bending details is to be prepared, and then whatever bar bending detail is prepared, then we can quantification of reinforcement, and then quality standard, what quality we need to mention, and then review and approval. Why review and approval required? Because we have made that one, and somebody has to check, third party or the client or the consultant or the structural designer will check, yes, as per that it is making the as per the design, as per the specification, and as per the code. We cannot forget the code also, which is mentioning the step-by-step details procedure that also need to be followed whenever we are preparing bar bending schedules. And then after getting the approval, it will to be documented, then communicated to the concerned parties and the concerned authorities, and it will going to the downward who are working on the projects, that is engineer, foreman, and the steel fixer itself, so that they can cut and bend and place the bar according to the requirement. And then periodic updates. Suppose is any GFC drawing is changes, and if there is any structural changes, so accordingly we need to change our bar bending schedule also. Again, then getting the approval, we need to provide this new bar bending schedule, and we have to take the old one, so that there will be no mismatch and there will be no chances of the product non-conformity. So these are the steps to be followed whenever we are preparing the bar bending schedule, that is understanding the structural drawings, identification and schedulings, bar bending details, quantification of reinforcement, quality standard, review and approval, documentations, communications, and periodic updates. So these are all the preliminary things or the fundamental things about the bar bending schedules. In the next video, I will discuss how to prepare the bar bending schedule with detailed calculation, and I will start with the foundation, then column, then beam, and then slab I will go. So the next video, I will make it fully how to prepare bar bending schedule of the foundation. So if you find this video is useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notifications. And if you want to know anything about construction procedures, material, and quality control procedure, please let me know in the comment sections, so that I can come with the more content like this. And the comment section is completely yours. uh, Express your comments, so that from your comments everybody can benefit it. And thank you again for watching me, and stay tuned, and thanks, and subscribe again for my channel.